Assalamualaikum and good day everyone. My name is Muhammad Irfan Daniel bin Hidizani, and today I'm going to present our assignment fluid mechanics, and my group members are Arman Kushairi, Zarif Ikram, Nona Jihad and Dana Silen. Next slide. For introduction, fertigation is a system or technique used in farming that helps farmers save time, resources, and energy. Fertigation is a combined process of fertilization and irrigation. It involves injection of chemicals into an irrigation system. The purpose of this project is to study the velocity, flow rate, losses, and distribution of pressure of a flowing pipe for water fertigation system. This project will include the use of Bernoulli's principle to analyze the data and flow recorded. Two types of pipe configurations are applied in these assignments. The pipe configurations are straight line and closed loop. From these configurations, data such as maximum flow rate, velocity, maximum achievable jet, and maximum pressure in pipe are taken to determine ideal pipe configuration for fertigation. For the theory, while the flow rate and velocity are related, they are quite different in terms of physical quantities. Flow rate works depending on the size of the cross-sectional area. The equation that described the relationship between flow rate and velocity is Q equals to AV, where Q is flow rate, A cross-sectional area, and V velocity. Thus, can be concluded that flow rate is directly proportional to both the average velocity and the size of cross-sectional area. Okay, that's all from me. Thank you. I pass the slide, the presentation to the next person, which is Zarif Ikram. Thank you.
Assalamualaikum and good day. My name is Zarif Ikram and I will explain the Bernoulli's principle. Bernoulli's principle states that on an increase in the speed of fluid occurs simultaneously with a decrease in pressure or decrease in the fluid's potential energy. It also explains the flow of fluid was one of the earliest examples of conservation of energy. During flow, the energy of any points in a conduit is the sum of the velocity head, which is denoted as V, pressure head, P, and elevation head, Z. All related in formula, which is energy is equal to velocity head by pressure heads plus the elevation heads, which is equal to a constant. It takes the form of conservation equation where the sum of the three variables will always remain constant as long as no losses or additions occur. Next slide, please. Okay, so the objective of the assignment, which is to perform the experimental and simulation flow exercise in the hose pipe, either in closed loop pipe and also a open loop pipe. And it is also to analyze the pressure variations in hose pipe of a specific length with two different configurations, which is open and closed loops. And then throughout the experiment and at the end of the assignment, we should determine and get the result of inlet and outlet pressures, inlet velocities, density and viscosity of water, and also to determine the Reynolds numbers. This activity has been done before the experiment started, which to determine the maximum flow rate, V dot, and velocity, V1, from a hose pipe. Based on the Bernoulli equation, we have calculated the maximum pressure in pipe P1. The system has been assumed to be frictionless. I will pass the slide to next group members.
Hello everyone, myself Dana Silen and Alalaki Dev Silen, metric number B092010410410. Today I'm going to explain about the procedure of the open loop. A 5-meter straight pipe already marked with 10 holes with same distance in between. Each hole was fitted with 5 mm single connector. The end of the pipe blocked from the water flowing out by using a stopper. The straight pipe was connected to the water source and the water was flowing at the maximum level and the observation was recorded. The time taken for 100 ml was water filled up in measurement tank was observed and recorded. The observation was taken from each of the holes and recorded for data analysis and calculation. Next slide, please. Procedure of closed loop. By using the same pipe that been used to run the open loop experiment, we used a T connector to connect the end-to-end pipe with the straight pipe connected to water source pipe. Once all the pipe are connected, the pipe already been in a closed loop state. The water flowing out into the closed loop with the maximum level and the time for 100 ml water filled up in a measurement tank was recorded. The time taken for 100 ml water filled up in the measurement tank was recorded for each of the hole. So according to the formula for the maximum pressure, so we get the data we collected and we get the pressure one, which is 106.230 kPa. Next slide. This is the data for time taken filling volume of 100 ml for each holes, which is 1 to 10. Next slide, please. And this is the data of the open loop straight pipe for the first hole to 10 hole, and time taken filling for volume of 100 ml. Next slide. And this is the data of the closed loop. Next slide, please. And okay, this will be explained by the next member. Thank you.
Okay. Assalamualaikum, my name is Najiha. So I will explain the analysis simulations. So for the simulation, for the first simulation, I will explain about the straight line configuration, particle movement. So for the first straight line pipe, the inlet pipe diameter is bigger than the outlet. So the movement particle in the pipe is actually freely rather than the outlet. So the second one is average flow. So the movement particle from the inlet will go to the end of the pipe, and the end of the pipe is actually blocked. So at the end of the pipe have a small turbulence, and it's more focused to the end of the pipe outlet. And the second simulation is closed loops configuration particle movement. And as you can see, the closed loop, the inlet movement is more rather than the others part of the pipe, and the outlet movement is actually bigger pressure than the others pipe size. So the second one is closed loop configuration for the average flow, and as you can see at the end of the outlet, which is have small movement of water flow rather than the inlet of the pipe. Okay, for the discussion, an increased definition in terms of fluid mechanics according to Bernoulli's principle assume that an increase in a fluid speed occurs at the same time as a drop in static pressure or a drop in a fluid's potential energy within a horizontal pipe that changes diameter. Regions where the water is moving fast will be under less pressure than regions where the water is moving slow. In this experiment, two sets of pipe configuration of flowing fluid is set up. The value of pressure and velocity is determined by how high the water bursts from the hole using the Bernoulli's theorem. After obtaining the results, we have found out that the pressure of water flowing through the straight line setup is lower than the water pressure of the closed loop setup. This is probably because in closed loop setup, the flow splits and meets back at each end cause a clash in flow, thus make the flowing path smaller and increasing the pressure. Whereas the flowing water in straight line setup has a less obstructive flow in a single path and exit through the pocket holes. This is relevant to the data gathered as the burst of water from the hole of a straight line setup is higher than the burst of water from the closed loop setup. Thus, it can be safely said that this experiment is done correctly and matched with the of Bernoulli's theory and principles. So I pass this presentation to the others members.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Arma Gushari and I'm going to explain about the explanation of differences between data obtained in experiment analysis. So, after we have done this experiment, we have gathered and conclude that there are difference between the data that we obtain by the experiment and the analysis, which is the data obtained between experiment analysis simulation have some difference due certain error that might occur during the experiment. Second, the experimental value cannot be obtained as sharp as analysis simulation, which is faster and more accurate. Third, error might be occur in the simulation as well, but not as obvious as in the experiment. The error that might occur in the experiment can be caused by human error, apparatus error, and data reading. So what we try to say here, which is the apparatus that we have made, maybe there are errors such as the holes might be bigger than it's supposed to be, and the distance between the each hole maybe are not equal as what we can set by doing the analysis. So next slide. So for the conclusion, as a result, the experiment was able to build a completely working fertigation system with a low cost component. The greatest possible water jet, which is M, mass flow rate kg per second, average velocity meter per second, and pipe pressure kPa can be calculated using both straight line and closed loop water hose configuration. Overall, the straight line water hose arrangement has greater value than the closed loop water hose configuration. Aside from that, this project can solve problem with missing variables using the principle of conservation of energy, a Bernoulli equation.